All right. For this part, we're going to focus on just visually what a graph may look like. So for the moment, we are not actually going to, change to a pen here, find the equations algebraically. Okay. But we can still talk about what it means to be an inverse. So if I were to make an x, y table for this function, let's call it f of x, then the 3 points that I could use would be -3, -2. I'm just picking 3, by the way. There may be more. -2, -1, and 1, 0. To find its inverse, I am simply going to switch the x's and y's. To find the inverse. So I did have -3, -2. Now I'm going to have -2, -3. I did have -2, -1. Now I'm going to have -1, -2. I did have 1, 0. Now I'm going to have 0, 1. Plot those points. So -2, -3 puts me right here. -1, -2 puts me right here. And 0, 1 is here. So notice that is half of a parabola. To be an inverse, it is always going to reflect across the line y equals x. So this line that I'm currently drawing, it's a perfect diagonal 45-degree line. I say perfect, human error there, but in real life, if it were drawn exactly how it's supposed to be, it will be a 45-degree. So notice that if I were to fold on that 45-degree line, that the orange would touch the other graph. That's how I do know that they are inverses of one another. The last part that we want to identify is whether or not it is 1-to-1. So looking at my original function, so ignoring the orange one for a moment, going back to the black/purple one, depending if you're counting my points or the line that it was there. Vertical lines never crosses twice, so it's definitely a function. But what about horizontal lines? So looking at the original function, if I keep drawing horizontal lines, you got to think about these horizontal lines being really skinny, so skinnier than the ones that I've drawn. If they were super skinny, it would still only be one spot at a time that it was touching. So yes, this one is 1-to-1 because it passes vertical and horizontal line test. Okay, let's look at the next one. Changing back to the purple color here. The original function we'll call f of x. 0, -2 is a point. Looks like 1, -1 is a point. And -1, -1 is a point. So that means for its inverse, I would flip those and get -2, 0, -1, 1, and -1, -1. So -2, 0, -1, +1, and -1, 1. Now, after my inverse is drawn, it's easy to see that that one does not pass the vertical line test. But if I want to determine if something is 1-to-1 before I have that drawn, I do the horizontal line test. So horizontal line test, this crosses here and here at the same time. So this one is not 1-to-1. Okay. So just so that we have that picture there, I'm going to draw that back real quick. A sideways parabola a full parabola, its inverse will not be 1 to 1. However, notice that this one is actually half of a parabola, and that's because the square root function is the positive part of a parabola. So that actually makes a little more sense than one would think when talking about it. All right, and for the last one, if I'm given 3 points here, same idea. -1, 0, 0, 1, -2, -1. I think about, does that pass the horizontal line test? Yes, so it is 1 to 1. And my other function is 0, -1, 1, 0, -1, -2. And notice that that is a cube root function, or sorry, a cubed function, and that our original was a cube root function. Next, we'll talk about how to solve algebraically, but in the meantime, you got a couple of activities on the slides to try to see if you understood what